All right, so significant figures are something that you typically don't have to deal with in high school science until you take a chemistry class, okay? A lot of people don't really deal with it in physics until they get to higher levels at least. You don't have to deal with it really in biology. But where chemistry is a physical science, it deals with a lot of math and it deals with a lot of numbers. And in the lab, you collect a lot of data that is quantitative in nature or involves those numbers, okay? So, think to yourself, have you ever asked your math teacher or your science teacher before the question, how many decimal places do you want me to round this to? And they kind of shake their head and say, round to this place or round to that place. And every teacher says something different, right? Because they all have different interpretations of what is reasonable and what is not. Well, the cool thing about chemistry is there is a set of rules that we have in place so that everyone rounds to the same place all the time, okay? Now, it's not going to be the same decimal place in every problem ever, but with the rules in place, any chemist that were to work out the same exact problem as you would still round their answer to the same number of decimal places, and that's what's cool about these. Unfortunately, though, you've never seen these rules before. So you're going to have to learn them, and you're going to have to commit them to memory, and you're going to have to never forget them, okay? We're going to use them all year because we're going to do math all year, all right? So, and again, significant figures are what they're called, but significant figures is kind of a mouthful. So I lovingly call them as sig figs, and a lot of other people call them sig figs also. Sometimes I abbreviate them as SF, especially on notes and stuff like that, just because it's extra brief, but sig figs is generally what we say out loud. So the first rule for sig figs is that non-zero integers are always significant. So if you have a number and it has no zeros in it, every digit in that number is significant. So 1, 2, 5, 9, none of those are zero. They're all significant. So I have 1, 2, 3, 4 total significant figures. Now, when you do have zeros, you have some other categories that you have to consider because it matters where the zero is located in the number, okay? Now, there are 3 types of zeros. Leading zeros, or zeros out in front of non-zero digits, are never significant. We never count them. So back up here, these 10 or so zeros that we put in front of this 1, 4, 5, 6, none of those would be significant. They're just placeholders, okay? Just placeholders. So none of these zeros are going to be significant. The only digits that we have significant here are the 4 and the 3. So this number, while it has a lot of digits in it, only has 2 sig figs, okay? Captive zeros, which are zeros in between 2 non-zero digits, are always significant, okay? So if you look at this example right here, I have a 2, a bunch of zeros sandwiched in between a 5. All of those zeros are between 2 non-zero digits, so they would be significant. So this would be significant, this is significant, this is significant. All of these digits are significant. And we would have 1, 2, 3, 4, 5, 6 sig figs. Now the last case is trailing zeros, and it's the tricky one. Trailing zeros are only significant if there is a decimal point. Trailing zeros are only significant if there is a decimal point. So if you look at this one right here, I have a 4, I have a decimal point, and now I have 1, 2, 3 zeros at the end. Is there a decimal point in this number? Yes, right? That means that these trailing zeros are now significant. So I have 1, 2, 3, 4 significant digits. What about that makes them significant? Well, if those zeros weren't significant, there's a much easier way we could have written that number. We could have just said, oh, that's 4. But this person chose to put those extra zeros on there. they're not place holding anything. 4 is 4, right? 4.000 is the same thing as 4. But we chose to include those zeros, which means that they are important, okay? So since we have that decimal place, these are significant and we do need to include them. If you look at this one right here, I have 3000 decimal point. I have a decimal point in my number, right? And I have some trailing zeros. That means that those trailing zeros are significant, okay? So I have 1, 2, 3, 4 total sig figs. And this last one is 1920. I have a trailing zero. Is there a decimal place? No. That means that we had the opportunity to call that zero significant. We could have put a little decimal point right there, in which case we would have 4 sig figs, but we don't. Because the person that made this measurement or communicated this number did not have a decimal point after this 0, it was not significant. Only the 1, 9, and 2 were. So this one is going to have 3 sig figs. Okay, so let's flip this over now and go to the next page. The very last rule, and this is one that last year in particular my kids really struggled with, and that is that exact numbers have an unlimited number of significant figures. Now, what are exact numbers? Okay, exact numbers are things that we know absolutely to be true. Okay, for example, we know that there are 2.54 centimeters in 1 inch, exactly. I could go through and add as many zeros as I were to ever want to the end of this 2.54. I could write it as 2.540. I could write it as 2.5400000. Okay? All of these numbers would be correct. Okay? So, in essence, this number could be changed to include any number of sig figs that I would ever want. It's an exact number. It's not rounded. Okay? It is what it is. It is a fact. Okay? 60 seconds in a minute. 60 seconds in a minute doesn't limit me to 1 sig fig, because instead of writing 60 as 60, I could also write it as 60 decimal point. And then I would have 2 significant figures, but I'm still saying the same thing. There's 60 seconds in a minute, and that's not changing. Okay? I could write 60 point and then 30 zeros after it to make it 32 sig figs. But it does not change the fact that there are still 60 seconds in a minute, okay? Same thing with 24 students in a class. Anything that is factual, not rounded, exact, you have an unlimited number of sig figs. And a good general rule for that is that anything that is not a measurement that is made in a lab setting is an exact number. Okay, and you'll get used to that distinction as we go on and use sig figs throughout the year. Okay, so right here I have 5 practice problems for you. Okay, and I want you to go ahead and pause the video, and I want you to break down every one of these, all 5, and make a prediction on how many sig figs you think are in each one. You can look back at your rules that you have, but try and use them less and less as you go, so you're kind of committing them to memory. So pause the video. All right, moment of truth time. Looking at this first one right here, I know that this is significant, this is significant, this is significant. I have a 0. Oh no. This 0 is in between 2 non-zero numbers. That means it's captive, and that means it is significant. This is significant, this is significant. So every digit in this number is significant. That means I have 6 sig figs. This number right here, I have some leading zeros. Are leading zeros significant? Never. So I don't count these, but I can count my 4 and my 5. I have another captive 0, it's in between, and I know that captive zeros are always significant, so this is significant, and the 8, of course, will be significant. So I have 1, 2, 3, 4 sig figs. All right, next one. I have a 2, which is good. These 2 zeros are captive. Captive zeros, always significant. So I've got 1, 2, 3, 4. Then I have these trailing zeros. Are these trailing zeros going to be significant? The answer lies here. There is a decimal point, so yes, they are. So all of these digits are significant, and we have 6 again. All right, this one right here is just a plain old 40. I have a 4, and then I have a trailing 0. It's at the end, but there's no decimal point. That means that the only significant digit in this number is the 4, so I have 1 sig fig. And my last one, I only have a captive 0. It doesn't matter that there's a decimal point or not. That's just how they communicated this number, and that's fine, but I don't have any trailing zeros there anyway. So all of these are significant, and it's just going to be 4. Okay, so I hope you found success with those, and if you're looking for more practice, you can Google sig fig practice just about anywhere and pop up with some more, but you will have some homework and things like that where you get to practice it too.